Bharat, should we start?
Yes, Bhumika,
Okay.
could you please introduce to Nirupama?
Hello everyone. It is a matter of great pleasure to introduce today's speaker, Nirupama Sharma. She completed her bachelor's and master's degree in physics with specialization in nuclear physics from University of Delhi. During this, she worked on a couple of project works in nuclear power plants of India. With this experience, she developed interest in nuclear energy and her website is a proof for the same. You may check www.betterenergy.net where her sincere efforts are visible. She is currently registered as a PhD student in Notre Dame, Indiana. With these words, I now welcome her to present her talk. Nirupama.
Hello, everyone. Thank you for the kind introduction. So, the talk that I'm about to give today is a part of an initiative that I have started. The name of the initiative, as you can see here, is Nuclear Energy, the Better Energy. Through this talk, I hope to be able to convince you all that we do need this initiative, and now is the best time to actively participate in something like this. Um, Before I proceed, I just want to know, can everyone hear me all right?
Yes, yes.
Oh, okay, sounds good. So I'll start with talking about why did I need to start this initiative in the first place. The first and foremost reason was I wanted to bridge the gap between my research as a nuclear physicist and my responsibilities towards the society. And I wanted to have the society get rid of their misconceptions and irrational fears about radiation and nuclear power. Moreover, we are at a point right now where all safety related fears and apprehensions have become outdated, and nuclear energy community has developed enough expertise to provide the world with a low risk, cheaper, and an environment friendly power. Now, at this point, we need to use the expertise of specialists in the field, like students who have PhDs or postdocs, and they need to help the public make well informed and educated decisions about nuclear power that could eventually help save the world. This slide shows the three major challenges that we as nuclear scientists face while addressing the general public about the benefits of nuclear energy. The first and most difficult challenge is the misrepresentation and use of inflammatory language by media. Then, of course, there's lack of knowledge and awareness amongst general public. And both of these lead to a fear of radiation and anything followed by the word nuclear. I like to call this nuclear and the fear factor. So this shows examples of how media frenzy occurred after some of the nuclear accidents like Chernobyl and Fukushima. You can read some of the headlines here. Effects to linger for decades. Nuclear nightmare. Nuclear nightmare is here. Scientists term radiation a peril to future of man. Fukushima's radiation reaches unimaginable levels. Now, these are perfect examples of how media has time and again misled the public into believing that nuclear power has caused more damage than what actually happened. For example, people in Fukushima died due to the hasty evacuation procedure started by the government. Nobody actually died of radiation poisoning, but media never reported that. What happened at Chernobyl was a classic example of the worst reactor design, worst operational practices, and the truth that Chernobyl type accidents cannot occur in the present day reactors. Now, misrepresentations and use of provocative language is a very big barrier that we as scientists have to deal with while convincing the society about the benefits of nuclear power. Marie Curie said that nothing in life is to be feared, it is only to be understood. And now is the time to understand more so that we may fear less. This served as a motivation for starting this initiative. So, where did we start with? We needed a platform that serves as an easy to approach resource and it needs to be clear, accurate, credible, and interesting. So I started with designing a website, thebetterenergy.net. The website has been designed in a user-friendly and easy to understand language. The aim is to be able to use this website as an educational and informational resource for anyone over the age of 15. And to attract more people and get more traffic on the website, it has been linked to a Facebook page of the same name, Nuclear Energy, the Better Energy. On the left here, you can see a screenshot of the homepage of my website. You can also visit the website, the link is right here. Um, then the website has been divided into 5 sections. The first 3 are health impacts of radiation, nuclear power generation, and nuclear reactor safety. Each of these 3 sections currently has 3 articles each. The fourth section involves a detailed explanation of the Indian nuclear power program. Now, because I'm from India, I wanted people from India to also be involved in this initiative. Moreover, the nuclear power program of the India and the US, they are very different. So including this section in my website, I thought it would help the public to develop a better understanding of the program of 2 major countries. Finally, a fun quiz section has been included with questions from the above 4 sections. And the website has also been linked to the US Nuclear Regulatory Commission for credibility. Now, the implementation of the initiative involved organizing various outreach events for primary and middle school students to introduce them to the concepts of nuclear physics through various demonstrations. You can see some pictures here. Here we had organized a demonstration for little kids and parents. We had Geiger counters and some objects from everyday use that we were showing to people that we can actually count radiation coming out of these objects using a Geiger counter. And I also delivered lectures to high school students about working of nuclear power plants and their safety features. Additionally, I have organized a platform to interact with parents and answer their questions about radiation and nuclear safety. So before we start, it is important to know that the motive of this talk is to open a platform for dialogue about nuclear science among specialists in the field and the general public so as to remove any misconceptions and irrational fears that the society has about nuclear science. And to be able to do that, it is important that the concepts be explained in a non-specialist way, that is, in a language that can be easily understood by the general public. So we have to get rid of all the jargon and make it as easy as possible. Um, so I thought that it would be interesting to include some pop quizzes. I don't know how it will work out on Skype, but let's see, which do you think leads to a greater average annual radiation dose? Option A, living within 50 miles of a nuclear power plant. Option B, living within 50 miles of coal power plants. And option C, employee at the Grand Central Station, which is in New York City. I'll give a minute for thinking about this question, and then we'll get to what the right answer is. Okay, so the right answer is option C, employee at the Grand Central Station in New York City. It might be surprising because living within 50 miles of coal power plants adds up to 0.03 millirem to the average annual radiation dose of a person, while living within 50 miles of a nuclear power plant adds only 0.009 millirem. However, if you're an employee at the Grand Central Station at New York City, your average annual radiation dose is increased by 120 millirem. It is attributed to the high uranium content of its granite walls. People often find this very interesting because they usually think that they would receive a lot of radiation by living close to nuclear power plants and not elsewhere. So that is why this is important, just to let people know that you can receive radiation from other places as well from the background, and depending upon where you live, the level might vary. Okay, so talking about creating awareness amongst the general public about nuclear energy, we need to look at all the aspects one by one. We'll start with the availability of fuel. Now, one of the very first problems that we solve while taking a class in nuclear fission is to calculate the amount of energy released by burning 1 kilogram of uranium. So, what we get tells us that the amount of energy produced by 1 kilogram of uranium is the same as that we get from burning about 2,750 tons of coal. Moreover, according to the US Energy Information Administration estimates, we have uranium to last over 500 years. And with reprocessing techniques and the use of breeder reactors, we can convert nuclear energy into a renewable source of energy, and then we don't even have to worry about running out of fuel. Finally, it must be remembered that electricity generation is not the sole purpose of coal. It needs to be preserved for some other industries like steel and fertilizer as well. So as far as availability of fuel is considered, uranium is doing a lot better than coal and all the other fossil fuels that we currently have. Coming next to the environmental effects, it is no longer a secret that burning fossil fuel emits huge amounts of greenhouse gases like carbon dioxide, carbon monoxide, sulfur dioxide, sulfur trioxide, and so on. These lead to global warming and result in environmental pollution, reduced rainfall, melting of polar ice caps, drying of rivers, sea level rising, and inundating low-lying coastal areas. It can also give rise to acid rains that pollute different drinking water sources, cause lung diseases, and whatnot. On the other hand, the process of uranium burning does not produce any carbon dioxide or any other greenhouse gases. And the only carbon dioxide that uranium burning releases is during the mining phase. And most importantly, all the radiation that is generated in a nuclear power plant is safely contained within the reactor building by thick lead and concrete shielding, which is called the containment structure, that is made all around the reactor to contain all the radiation that is generated by fission processes. So nothing of that gets released into the atmosphere if everything goes well. Now, talking about accident statistics, if safety is the prime concern, then this table tells us that nuclear should be our top priority. The data in this table reflects the statistics given by the International Atomic Energy Agency. We clearly see that while coal, natural gas, and hydro have caused about 18,000, 1,000, and 30,000 deaths of workers and public, nuclear, on the other hand, has resulted in only 31 deaths. And these 31 people to die were firefighting workers, not even members of the public. So these accident statistics brings us back to the challenges that nuclear power faces. Before proceeding, I would like to ask you all, have you ever heard of terms like deadly radiation or lethal radioactivity? And I'm sure that most of you would say yes to that. Yes, right. So everyone has heard about terms like deadly radiation and lethal radioactivity. Whereas, have you ever heard of terms like lethal electricity or lethal natural gas? And the answer would be no, right? So in spite of the fact that thousands die every year due to electrocution and suffocation accidents, we never hear terms like lethal electricity or lethal natural gas. Whereas nuclear accidents, all of them combined, have resulted in 31 direct deaths, and still it causes a lot more media frenzy. Hello, amigo. So the 31 people who died in a nuclear-related accident were firefighters who helped in dousing the flames after the blast of a reactor at Chernobyl by flying in a helicopter to the top of the reactor building. Whereas some of you might have heard about the Bhopal gas tragedy, where a gas leak incident occurred in 1984 at a pesticide plant in Bhopal, India. This accident resulted in 2,259 direct deaths, about 500,000 injuries, including 38,000 temporary partial injuries and approximately 3,900 severely and permanently disabling injuries. But even though such a major accident happened in a gas plant, in a chemical plant, we never hear about lethal, gas or lethal chemical plant, deadly chemical plants. We don't have protests, and we don't have activists talking about shutting down pesticide plants, whereas nuclear has to face and fight with all of those challenges as well. Now, among another aspects of why nuclear is better than other energy sources is because of its long lifetime and small land requirements. The designed lifetime um, is about 40 years and above for nuclear power plants, whereas for thermal power plants it is limited to just 30 years. Now, because of various reasons like corrosion and erosion, life extension may not be possible for thermal power plants. However, with better choice of materials and good maintenance practices, an extension of 10 to 15 years is usually possible for nuclear power plants. As a result, the generation cost beyond the lifetime of the plant will only include the running cost, and hence also makes nuclear energy cheaper. Now, coming to land requirements, for thermal power plants, the land requirement is about 0.5 to 1.2 acres per megawatt electric. However, for nuclear power plants, it is just zero point 0.2 to 0.25 acres per megawatt electric. Generally, a 1 kilometer radius is required for construction of a nuclear power plant. However, the actual plant occupies only a small percentage of the area, and in the remaining area, agriculture and common human practices can go on as usual. Now, we have seen all the aspects that are important in identifying nuclear power as a better energy source than all the other currently available energy sources. However, the most challenging aspect that hinders the future of nuclear power is the fear of radiation. As nuclear scientists, we need to be able to make the general public understand what exactly is radiation and how it affects our day to day lives. Now, Google will simply tell you that radiation is the emission or transmission of energy in the form of waves or particles through space. However, we never worry about any exposure that we receive by, say, sitting under a light bulb for 12 hours or listening to radio all night long or heating our food in a microwave. The reason is because there is a subcategory that any kind of radiation can be divided into: ionizing and non ionizing. Radiation like alpha, beta, and gamma rays, and X rays that can possibly do harm to living tissues by ionizing atoms or knocking off electrons from atoms, are ionizing, whereas radio waves, microwaves, and visible light that are on the lower frequency end of the electromagnetic spectrum cannot ionize atoms and are unable to cause any potential damage to the living tissues, are non-ionizing radiation. So this is important because every time I organize some outreach events for parents and kids, and if I have a Geiger counter in my hand, people do come up to me with their mobile phones and ask me to measure the radiation coming out of their mobile phones. They do not understand that the radiation coming out of their mobile phones is different from alpha, beta, and gamma radiations that can possibly do harm to them. So it is very important that while talking to the general public, we make a clear distinction between what exactly is ionizing and what is non-ionizing radiation, what can cause harm and what is harmless to them. So people often worry about the radiation exposure that they would be receiving if more nuclear power plants are built in their cities and close to habitations. Now, I like to tackle this question by asking a simple question in return. The first nuclear explosion which was the Trinity nuclear test, a part of the Manhattan Project, occurred in the US in 1945. And the first nuclear power plant to be connected to the power grid was in the city in Russia in 1954. So, did human lives start to get affected by radiation only after these events? The answer is a clear no. Radiation has been a part of human life since the beginning of time. And there are two major sources of radiation emission, natural sources of radiation, which we often call as background radiation, and artificial sources of radiation. We'll look at each one of them individually.
So, Nirupama,
Um,
hello.
yes,
So I have a
yes.
question. So, in what way is nuclear energy climate friendly?
It is climate friendly because so while you're burning coal, it emits carbon dioxide and sulfur dioxide and lots of other greenhouse gases, whereas when you're burning uranium you do not produce any greenhouse gas, right? And as I told in one of my earlier slides, the only carbon dioxide that is produced in the entire nuclear fuel cycle is during the mining phase. And when you compare that with the amount of greenhouse gases that other fossil fuels produce, it is a very small percentage. So that is why we say that nuclear power plants are climate friendly. They do not lead to raise in the global temperature. They do not lead into water or other areas around it getting flooded or with, so for example, with hydroelectric power stations, lots of places get underwater and it ruins all the uh, ecosystem in that area. That does not happen with nuclear power plants. So keeping all of that in mind, we know that nuclear is climate friendly.
Okay.
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 Thanks.
So we will start with the natural sources of radiation. This can be divided into three categories: cosmic rays, terrestrial radiation, and internal radiation. So the first natural source of radiation is cosmic rays. These are immensely high energy radiation, mainly originating outside the solar system. They may produce showers of particles that penetrate and impact the Earth's atmosphere and sometimes even reach the surface. Cosmic rays are composed primarily of protons and alpha particles, and a small amount of heavier nuclei. So when cosmic rays enter the Earth's atmosphere, they collide with atoms and molecules, mainly oxygen and nitrogen in the atmosphere. This interaction produces a cascade of lighter particles that rain down on everything on the surface of the Earth. Now, the exposure received by cosmic radiation differs for different regions depending upon their elevation. But the average dose as received from cosmic radiation is about zero point zero 0.04 rem per year. Rem is a unit of radiation dose which can be applied to human beings. Talking about a consequence of radiation from cosmic rays. Now, few people realize that taking an intercontinental flight exposes them to radiation far greater than what they receive from the nuclear fuel cycle. The exposure on such flights is due to the exposure from cosmic rays, which increases with altitude. Now, the longer you are on a flight, the more radiation you receive, and the higher you are up in altitude, the higher the dose of radiation. So, an annual jet travel can add up to 10 millirem of radiation dose to humans. You can read more about this on my website, and the name of the article is Radiation and the Fear Factor. The next natural source of radiation is terrestrial radiation. Now, the Earth that we live on is in itself a source of radiation. Radioactive materials like uranium, thorium, and their decay products occur naturally in rocks, soil, water, and vegetation. The most harmful of all these decay products is radon. Radon is a gas that can be inhaled, and once it reaches our lungs, it can decay to solid daughter products and get stuck in the respiratory system, causing harm. Um, so the exposure received by terrestrial radiation also differs for different parts of the world depending upon the uranium or thorium content of the soil of that area. For example, if you live in Kerala in India, um, you receive a higher background dose from terrestrial radiation because in the sands in Kerala, there is a mineral called monazite, which is very rich in thorium. So you end up receiving a lot more radiation if you live in that region, where as compared to whether if you're living in some of the other regions, like in the northern part of India. So the average dose from terrestrial radiation is about zero point 0.2 rem per year, and as I said, this differs for different parts of the world. Coming to the consequences of terrestrial radiation, the first is radon accumulation in basements. Now, as I said, radon is a radioactive gas that is a decay product of uranium and thorium. Now, since both uranium and thorium are found in rocks and soils in small quantities, radon is released in the environment from these sources. It does not have any smell or taste, but can get problems due to its radioactive nature. Radon can enter buildings or houses through openings and cracks in the floor or through construction joints and get trapped if enough air circulation is not possible. So radon accumulation mostly occurs in basements and enclosed spaces within buildings. The average dose received by a person from radon in the atmosphere is about 200 milligram per year, and radon poisoning accelerates if the person is a smoker. We'll talk a little later about why that is in more detail. Another consequence of terrestrial radiation is the radiation that we get from drinking water. Now, the drinking water in our home usually comes from rivers and lakes. Radiation can enter the water stream from natural sources like rocks and soil. In the United States, the level of radiation in drinking water is very low. It is only about 5 milligram per year. And again, it varies from place to place. Coming to the last natural source of radiation, internal radiation. All living beings on Earth have potassium 40, carbon 14, and lead 210 in them from the time of their birth. These are radioactive elements that get absorbed by the body and keep getting replenished over time. The exposure received by an average man in the US by internal radiation is about 0.03 rem per year. The consequences of internal radiation is that you can get radiation just by sitting next to a person. So just by sitting next to a person, you will expose yourself to radioactivity arising from the internal radiation emitted from that other person's body. Now, as we saw in the last slide, all living beings on Earth have these three radioactive elements, potassium 40, carbon 14, and lead 210 in them from the time of their birth. These may arise due to consumption of food, drinking water, or simply inhaling air containing radioactive elements. These elements are absorbed by the tissues and bones in our bodies and keep getting replenished over time by simple processes like ingestion and inhalation. Yeah, this is again, this is the same number that we saw in the last slide, 0.03 rem per year. Now, transitioning to the artificial sources of radiation. This can also be further subdivided into three categories: nuclear medicine, consumer products, and the nuclear fuel cycle. We'll start with nuclear medicine. So the most radiation exposure as received by the general public from man-made sources at present is by medical procedures such as X-rays, radiation therapy to cure cancer, and medical imaging, wherein radioactive material is injected in the body to check for various diseases. Any patient undergoing such a procedure will receive a radiation dose. Now, the radiation doses delivered to a patient in such an investigation is generally very small and does not pose a risk of inducing cancer. For example, the effective doses can range from 0.006 to 3.7 rem for non-specific tumor imaging procedures, and a typical chest X-ray exposes you to about 0.002 rem, while a chest CT scan can result up to a dose of 0.2 rem. The next is consumer products. There are various products that we use in our day-to-day life that result in um, the general public getting exposed to radiation. So the first and foremost is a smoke detector. These are very common these days, and most households have smoke detectors installed in their houses for safety against fire. Now, most smoke detectors use a small amount, about 1 microcurie of americium-241, which is a radioactive source and decays by emitting alpha particles. Now, this on the right here, you can see the working of a smoke detector. These have three major components: the ionization chamber, a radioactive source, and a battery. The ionization chamber consists of two metal plates held at different voltages. The americium-241 source emits alpha particles that interact with air molecules in between these two plates, and this interaction causes the air molecules to ionize. And then the positive and negative ions flow towards the negative and positive plates, respectively, and this flow results in an electric current. Now, if there is smoke in the air, the smoke particles get stick to the ionized air molecules. As you can see here, the blue is the smoke particle which has gotten stuck to the some of the ionized particles here, which are shown in black. And this leads to an obstruction in the flow of the charged particles to the metal plates. The obstruction that happens, it leads to a decrease in the electric current, and it is this decrease in current which is detected and triggers the smoke alarm. So most modern smoke detectors emit about 37,000 alpha particles per second. However, the americium source here, it is encased in ceramic and foil, so very few of them can actually exit the detector. The energy of an alpha emitted from americium-241 is about 5 MeV, and this can be stopped by a piece of paper or a few centimeters of air and cannot penetrate the human skin. So unless it is directly inhaled or ingested, the americium source in a smoke detector does not pose any threat, and therefore the average dose from a smoke detector is very less. It's about 0.008 millirem per year. Um, the next consumer product is building material and soil, which exposes uh, us to about 7 millirem per year of dose. So sandstone, brick, concrete, gypsum, and granite, all these are used as building materials, and they contain naturally occurring radioactive elements like radium, uranium, and thorium, and act as a source of radiation. Radiation dose from building materials largely depend on the type and amount of material used. However, the level of radioactive materials in such buildings is very low and does not pose any threat to human health. And living in concrete building adds only up to 7 millirem per year to the average annual radiation dose of a person. The next is uh, smoking. So tobacco has a property to absorb radon from the atmosphere. Um, Radon, along with smoke, is inhaled by the smoker. Now, radon is a gas which decays into solid radioactive products like polonium and lead. So, gaseous radon enters the respiratory tract and soon starts decaying into solid radioactive products. These solids can get stuck in the respiratory tract and lungs and stay there for a very long time, continuously decaying into other radioactive products. Over the years, this accumulation can prove seriously dangerous and oftentimes fatal. Now, this will not only just affect the smoker, but also anyone and everyone near the smoker who is knowingly or unknowingly inhaling the contaminated smoke. Smoking can add up to 1.3 rem per year to your average annual radiation dose. I talk in a lot more detail in my article "Smoking Kills" on my website. So you're you can refer to this article later if you would like to know more about how smoking can cause cancer. And though there are other carcinogenics involved here, my article focuses on how radon absorption by tobacco leads to an increased chance of contracting cancer. Um, the next is Fiesta Wear. So if you were born before 1972 and ever used the orange red color, colored Fiesta Wear, these are ceramic plates that were produced by a company during the 60s and 70s. Um, these were used as dinnerware. Now, back in the day, that special orange red color was derived from uranium oxide. Researchers estimate that one such plate would have contained approximately 4.5 grams of uranium. That being said, if you ate of that dinnerware daily, you would have almost 0.21 grams of uranium ingested per year. But not to worry, Fiesta ware manufactured after 1972 is not radioactive, and these days we can only find these dinnerware in antique stores. Television. So if you still use your old television set, the cathode ray tube in the machine exposes you to about 1 millirem of X-rays per year. The FDA monitors all TV sets and that are sold in the US to be tested to make sure that they do not exceed a safe level of X-ray emission. So nowadays we don't use cathode ray tubes installed in television sets. We usually have flat screen TVs and computers. They do not produce any X-rays. Uh, any guesses why? So it's just because we do not use cathode ray tubes anymore in the flat screen TVs and computers. These days we have better technology now, so um, we don't have to worry about that. But back in the day when these were still a thing, old television sets could expose you to about 1 milligram of X-rays per year. Now, coming to the last category of man-made sources of radiation, the nuclear fuel cycle. Surprisingly enough, the source that everyone is most scared of is in fact the least contributing factor to all the sources of radiation seen so far. The entire procedure involved in a nuclear fuel cycle, right from to um, mining of uranium to power production, exposes the general public to a much lesser radiation dose. To be specific, the average dose equivalent to the US population from the fuel cycle is only about 0.05 milligram per year, which is much less than the dose received by any of the natural sources of radiation. It is also less than any of the consumer products that we have just seen, and of course, much less than what typical X-rays or CT scans expose you to. Um, Bananas. I say that bananas are controversial because very few people realize that if they had a banana for breakfast, they actually exposed themselves to radioactivity. A typical banana contains about zero point 0.5 gram of natural potassium, of which 0.012% is potassium 40, which is radioactive. This roughly amounts to a radiation dose of about 0.01 milligram. Now, here's a fun fact. The radioactivity from a truck full of bananas can cause false alarms when passing through a radiation detection device set up to check on the smuggling of radioactive elements. So bananas are radioactive. Um, it's time for pop quiz 2. So as we just saw, bananas are radioactive. Eating how many bananas would be equivalent to the amount of radiation dose you receive from living within 50 miles of a nuclear power station? Option A, 1 to 100, option B, 1,000, option C, 10,000, and option D is 100,000. Any guesses? Okay, so the answer is option A, 1 to 100. Um, a typical banana, as I just said, contains about 0.5 gram of potassium, um, and that amounts to an activity of about 15 becquerel and corresponding radiation dose of about zero point zero 0.01 millirem. So yes, if you have lived near a nuclear power plant for a year, you have only received as much radiation as from eating at most 100 bananas. Low enough for your body to take care of it naturally. Another quiz. Which of these is a greater contributor to radiation or a contributor of radiation to the environment? Option A, fly ash produced by coal power plants, and option B, nuclear waste shielded via water and dry cask storage.
Let's say.
A, right. It's A because coal has radioactive uranium and thorium in trace amounts. When coal is burned into fly ash, uranium and thorium are concentrated at up to 10 times their original levels and leach into the soil and water surrounding a coal plant. In fact, fly ash carries about 100 times more radiation in the surrounding environment than a nuclear power plant producing the same amount of energy. So, we usually think that nuclear power plants are more dangerous, but that's actually not true. That's the point of all these quizzes. Um, moving forward,
So, Nirupama, could you please comment
yes.
about this recently heard news of Amazon fire or something? So, is there any effect in future because of?
So, talking about the environment, Amazon
Yeah.
fires, they are contributing to thousands and thousands of tons of carbon dioxide to the environment. And trees are getting burned. So one, it is bad to not have trees anymore, and then it is contributing to so much of carbon dioxide. It is producing so much more carbon dioxide than we would have had if the fires were not taking place. So that is a natural cause of environment pollution that is happening. We cannot really help that right now. But what we can do is limit the amount of carbon dioxide and other greenhouse gases that we are producing by burning coal and natural gas and move to other environment friendly energy sources.
Mm-hmm.
Okay.
Okay.
Um, okay. So, yeah, before we talk about this, I should tell you a little about NRC. The NRC is an independent agency of the US government that looks after and protects the public health and safety related to nuclear energy. NRC stands for Nuclear Regulatory Commission. There is a wonderful application on the US NRC website, also called the Personal Annual Radiation Dose Calculator. It allows you to convert your fear factor into an actual number by answering a few simple questions. This number is the total annual radiation dose that you have received depending on where you live, your lifestyle, and adds that to the average background radiation that you are ought to receive on Earth. Now, the average dose per person from all natural and man-made sources is about 350 milligrams, according to the USNRC website. However, it is possible for any of us to receive more than that each year, largely due to medical procedures. The US NRC has established standards that allows exposure of up to 5,000 millirem per year for those who work with and around radioactive material, and 100 millirem per year for members of the public, in addition to the natural background radiation. So this is what the dose calculator looks like. It shows radiation from cosmic rays and asks you for what elevation you live at, and then depending on that, so as I said, the exposure from cosmic rays increases with elevation from ground level. So you put in your elevation depending on where you live. Then it will ask about your area of residence. Unfortunately, it only gives an estimate for people living in and around the US, because terrestrial radiation again differs for different places, but you can still get an idea. Then it will ask you whether you live in a stone, brick, or concrete building. as I said, these all of these have natural uranium and thorium content in them and can add up to 7 millirem per year. Then it takes into account the internal radiation that we receive from food, water, and radon in the air. Then weapons test fallout, that usually does not happen. Then you can put in how many miles of jet travel you have had annually. Um, then it will ask you to select out of these options whether you have porcelain crowns, use lantern mantles. So back in the day, lantern mantles that were used, they used to have thorium in it, and that was quite radioactive. Whether you wear a luminous wristwatch, use luggage inspection at airports that has typical X-ray machines, watch TV, have a smoke detector, uh, plutonium-powered pacemaker. Have you ever had diagnostic X-rays in the last 1 year? Have you undergone any nuclear medical procedures? Whether you live within 50 miles of a nuclear power plant, and whether you live within 50 miles of a coal power plant. Now, again, you can see here, living within 50 miles of a nuclear power plant exposes you to much less radiation dose than what you get from living within 50 miles of coal-fired electrical plant. So once you have selected out of all these options and put in all the numbers that were asked here, you can calculate your average annual dose. So I did that, and my personal dose came out to be 330 millirem, which is less than the average annual dose per person from all natural and man-made sources of radiation of about 350 millirem, which is the government approved number for general public. Now, of course, if you have undergone a medical procedure lately, your dose will come out to be a greater number. But the point here is that you don't have to be living near a nuclear power plant, or you don't have to be working as a uranium miner to receive a radiation dose. This calculator, more than anything, makes clear that everyone living on this planet receives a radiation dose, albeit the number might vary depending upon your lifestyle and other natural factors. Another interesting thought that I came across on the same webpage goes something like this. The reduction in life expectancy from a dose of 1 millirem is about 1.2 minutes. This is equivalent to the reduction in life expectancy from crossing the street 3 times, taking 3 puffs on a cigarette, or consuming 10 extra calories for a person who is overweight. So currently, the general public is dealing with radiation exposure in numbers that are so less that they do not really affect their general health and public safety. So
Nirupama,
coming, yes,
I have a basic question. So,
yes.
how long does radiation stay in water?
Um, it depends upon a lot of things. So how, I mean, it depends upon the energy uh, of whatever radiation is in the water. So water helps because you might know about spent fuel pools that are made right very close to the reactor containment building, where used fuel rods are taken out of the reactor building and put in water so that they can cool down. And once they have cooled down and radioactivity has decreased to a safer value, these fuel rods are then taken out and sent for permanent storage. So water does help, but it depends a lot on how much material you're putting in, the energy, the amount of heat that is being produced. So yeah, there is not a fixed amount of time that I can tell you that this is the amount of time that radioactivity
And
stays.
another question. So, how the general public knows the radiation in the water? So, for
They
example,
don't.
water coming on the
Yeah.
home, and we don't know whether it is inside this water some
Right.
radiation or something.
Yeah.
So, how
So
the
so
general
that,
public knows
so
all these
that
things?
is exactly where we as specialists come in. We have to talk to the general public, and we have to make them aware that no matter where they are, if they are drinking water, they are ingesting lead 210 and potassium 40 from the water. If I drink water in my house and if I drink water elsewhere, I will be exposed to the possibility of ingesting radiation. That is what we want to tell the general public. You don't have to be living close to power plants, nuclear power plants, to receive radiation. You receive radiation just by drinking water at your home. You receive radiation just by sitting next to a person. You receive radiation just by eating bananas. That's the point I'm trying to make. Does that answer your question?
Yeah. Okay. Okay.
Okay. Okay. So coming back to the beginning, the idea is not to get scared of radiation, but to gain better understanding of what it is and how it affects our day-to-day life. We saw clear examples of bananas on transcontinental flights. So bananas are radioactive. Does it mean you need to stop eating them? No, right? Because it provides a vital need to your body, potassium. You need potassium, your body needs potassium, so you have to eat bananas. Now, same goes for taking long transcontinental flights that expose us to radiation from cosmic rays. If you need to, say, go to Japan, you have to take a flight. The subtle point here is that the human body has been subjected to radiation from background and other sources ever since it came into existence. Now, depending on where we live and our lifestyle, the amount of radiation that we receive might vary. But the important point is that our body knows how to handle it. It has been handling radiation and keeping us safe for all this time, even from before nuclear power plants came into existence, even before weapons tests were happening. Our body has been taking care of radiation and it has been keeping us safe all this time. To receive a fatal or a potentially dangerous dose greater than 1000 rem, you have to receive a lot of radiation, and certainly a lot more than what you receive from background or from the nuclear industry at present. Fear always comes as a byproduct of ignorance. Now it is time that we shed this ignorance about radiation and its ill effects and accept nuclear power for all the benefits that it can offer. And this is the reason behind the initiative that I have started, Nuclear Energy, the Better Energy. We need to help the society get rid of all the misconceptions and irrational fears that they have about radiation and help them make well-informed decisions in future so that we can have more nuclear power plants. We can actually work towards a better environment. We can hand down to our future generations an environment that is, if not better, we don't necessarily want to hand down to our next generation an environment that is worse than what we are currently living in. So that is why we need nuclear power plant, and this is the motivation behind the entire initiative. We need to talk to the general public. We need to help them get aware and make better decisions about nuclear power. Quickly looking at the progress report, so far this initiative has garnered about 176 followers and about 300 unique visitors per month. Efforts would be continued for the progress of this initiative, and if any one of you are interested, I would be happy to collaborate, get volunteers for fieldwork, and or even just to extend the website beyond what it is currently delivering. I would end with this quote from my website. 85 years of scientific experience and the nucleus has still managed to keep the entire mankind baffled. Such is the enigma of nuclear power. The immense energy that it releases can not only light your bulbs, but can also provide you medical assistance. It is something that stays inside your body, gets replenished every time you eat and breathe. You cannot escape it. You need it. Coal, petroleum, and natural gas won't last for your great-grandchildren, but nuclear power will. It is not necessarily the last resort, but definitely a greener, safer, and a better one. Thank you. I
Thank you.
will take questions now.
Thank you for very wonderful talk. It was really good to listen from you all the statistics and the facts, which I was personally not aware of much. So I belong to a general public only. So the talk is now open for discussion. Any comments? Bharat, Gagan.
Okay, so I will ask again one,
Yes.
just like a, a basic question. So if you calculate the average life for Indian population or anything, so the average life in India, if you are living in India, so the average life is nowadays is 70 years. Okay. And if you calculate the average life in Japan, if you are living in the Japan, so the average life is 80 to 90 years. Okay,
Okay.
so in Japan, this so many accidents happen in few years back. Why in the Japan the living life is more comparison to India?
Can you speak a little louder? I did not
Okay.
hear.
So my question is that if you are living in Japan,
Yes.
so the average life in if you calculate in Japan, it's about 80 to 90 years right now.
Okay.
Even though here so many accidents happen, like this reactor and many things. And if you are
Right.
calculate the average life in living in India,
Yeah.
so the 70 years maximum
Hmm.
average life. So why it is so much difference in Japan and India? Because of the in India the not only the radiation effect, maybe other effects.
Yeah, definitely. I mean, there are, I mean, I don't know as much about Japan, but I think a lot of other things have to be taken into account. The first is the pressure that the population exerts over the economy. I mean, India definitely has a lot more population than Japan, and a lot more people are living below poverty line. There is malnourishment. They do not receive basic health services from the government, and I'm guessing that is better in Japan. People are, I mean, their economy is better than India's is currently, and there are better health facilities available. I think that's major cause of why our life expectancy is less than what it is in Japan. I mean, nuclear is not the factor that is actually affecting this,
Mhm.
but yeah, I mean, I think if we can make more nuclear power plants in India, right now, our the amount of power that we get from nuclear power plants in India is about if we can increase that, I think we can reduce the amount of environmental pollution that people are dying because of suffocation accidents or accidents that happen at coal power plants or because of the extreme weather uh, conditions that like rampant floods or
Mhm.
droughts. We can reduce that. I mean, this won't happen immediately. It would take some time to for the environment to accept that and get that corrected, but I really think that if we can make more power plants, more nuclear power plants, and reduce on what we are doing with fossil fuels currently, we can increase life expectancy in India as well.
Okay, thanks.
I can see Palissari is here with us. Would you like to comment, sir? Anything? Alisa?
Yeah, I am just seeing the talk, so it's I don't have any. It's nice talk. I liked it.
Okay, thank you.
It's very nice talk. So will you be uploading this talk in the drive?
Yes. Maybe on Monday.
Huh?
On Monday on YouTube.
Okay, okay,
Yeah.
fine.
Yeah, and you can visit my website. And if there are any other questions, there is a contact page on my website where you can directly contact me with questions, whether it's about this talk or about general features of the website. I'll be very happy to answer any questions, or if there are any suggestions for improvement and extending the website beyond what it is currently offering, I would be very happy to.
Can you send me a link of this?
Yes, I can. I will. Yes.
Okay.
Yeah. It is also on the talk. It's right here. I can just go back to. Yeah, right here. Thebetterenergy.net.
Okay.
Okay, even I will mention on the this when I upload on the YouTube, I will mention on the something on the website also. This all these things. So,
Okay, then let us thank the speaker. Thank you very much again. It was a
thank you,
really
Nirupama.
wonderful.
Thanks. Bye.
Okay.
Okay, thank you. Bye.